a topology, how to configure it. I showed you here in my example how I configured. So basically all you do, router OSPF, any number you want to select, it doesn't matter. This is the process ID. Router ID is just basically what it does is the name of the router. How, my neighbor will recognize me. With what name would be recognizing me? So router ID we define under the OSPF. Then network statement. You don't put a network on statement on somebody's else network. You put a network statement for the one which is connected on your network sitting behind you. You put a network statements like this. And area 0 is always considered to be the backbone area. Understood? It's always considered to be the backbone area. So that's what you can, this is the process ID you can have from, you can use any number you want from 1 to 65,535, you know, any number you want to choose. This is only local to the router. It doesn't get exchanged. So router ID is a kind of identifier. That's what I'm trying to explain to you here. If you don't have the router ID configure like this, if you don't have the router ID configured, then what OSPF does, it takes the highest IP address, active highest IP address, and makes it as a router ID. So in our scenario, what is the highest IP address? This is the highest IP address, 199.199.199.1. So it's going to say, you know what? This is my router. This is my name. But when we define it here, the router ID, we're saying, you know what? Don't use the highest active IP address. Simply use this as my OSPF name for my router. Understood, guys? That's what they're trying to tell you here. Process ID, router ID, to just explain to you. Clear IP process is basically, restarting the whole OSPF routing table. This is how you configure it. I just explained to you. Show IP protocols, looking at all the protocols. Clear IP process, this is basically clearing the routing table. And the network wildcard mask is the reverse of subnet mask. Area, whatever area you're in. Simply right now understand area 0 is the backbone. So whatever, when you configure it, just configure it with an area 0. So this is what they explained you here. They're explaining you here. Router OSPF 10, any number, 1 to 65,535, any number you want to choose. It's only local to the router. Router ID, you want to choose anything you want, because why? It's an identifier. And this is the network, and this means the reverse of subnet mask. When you say reverse of subnet mask, it's 255.255.255.0, right? It's 255.255.255.0. And when you reverse it, it becomes 0.0.0.255, area 0. Same thing, 192.16.3, reverse it, 255.255.255.252. 192.168.10.4, this is 0.0.0. Sorry, 255.255.255.252. You're reversing it, right? Passive interface. What does a passive interface means? Passive interface means that in this scenario, this is a switch. Gig over here, I have a switch. So do not send any routing information. Do not send any kind of handshake to this interface gig 00, because why? I got a layer 2 switch sitting behind me, and I don't want him to be bothered with my routing updates or my routing table or whatever the networks I have sitting. I'm not going to be bothered by it because it's a layer 2, and layer 2 does not understand any of this IP addressing and all that, because why? It works on port and MAC address as a layer 2. Layer 3 devices are the one which works on your IP and your routing table and everything. Understood? Now, this is by default. Remember this. In the beginning of the chapter, I mentioned that the higher the bandwidth, lower the cost, right? I mentioned it to you. Higher the bandwidth, lower the cost. So now, if you look at this, before we were using 1.54, then Ethernet came, then fast Ethernet came, right? But in gig and 10 gig was not used widely initially. So if you look at these costs, the highest was what? 1 in the beginning with 100 meg. Now we got 1 gig and we got 10 gig also. But the problem is their cost is also 1. And this is completely wrong. 10 gig is a lot faster than 100 meg, right? So what happens is this OSPF got into this issue because OSPF came out when this was 10 gig and gig E's were not, in production, were not in use. Fast E was the max you can go up to, right? So that's why they, OSPF, whoever wrote this routing protocol, they came up with auto cost reference bandwidth 10,000. So every router, we put this auto cost reference bandwidth 10,000. What it does by just putting this line under the configuration, what it does, it automatically calculates the cost for you. So if you look at this, if you have not put this command under the OSPF, if you have, then your 10 gig and your FAST-E both had a cost of 1. But in this scenario, 1 cost 10, 100, 1,000, 6,477. By putting this in megabit per second, basically what we are doing is letting the OSPF calculate the cost by looking at the speeds. Understood, guys? So we have to make sure we put the cost in every single OSPF so they can basically go back to this. This is OSPF version point-to-point networks. When you have got two routers connected together, you know, if they're connected on the switch, basically switches, and it's a broadcast scenario. If two routers are connected directly together, then it's a point-to-point connection. Frame relay, bypass frame relay because frame relay is old technology. Nobody's using frame relay anymore. Point to multi-point means that you are basically connected to two routers together. From point to point is from one router to the other. Point to multi-point means that you've got one connection and you're getting diverted into two. So that's what point to multi-point means. This is area 0, area 1, area 51. If this guy wants to talk to this guy, there's something called virtual link configuration. All the traffic will be bypassing area 1. It's like a VPN tunnel on the internet, right? Everything is going on the internet, but through the tunnel. So that same concept is here in OSPF also. So the challenge is, I have never seen, only one time I saw it, if there are a lot of routers that are connected through one switch. I've not seen it. This is, only one time in 24 years, 25 years, I've seen that all the routers are connected to one switch. If you have this scenario, then there is a problem. Then basically you will have to use a designated router and and backup designated router, which I explained earlier. Because what will happen is everybody is going to be sending update to everybody. So if you have got 5 routers, what will happen? 5 minus 1, then basically divided by 2. Right? Everybody's going to be saying state acknowledgement, link state update. Everybody's going to be talking to everybody. So in order to avoid this, say, you know what, any changes happen in your network, you simply send, let's suppose to R1 and let R1 send it to everybody else. Do not, you guys, R3 should not be sending it to R5. R5 should not be sending it to R4, or R4 should not be sending it to R2. So that's what they're talking about here. So the designated router, as I explained to you, that I am the designated, our two scenarios. Here's the RSA from R1, and he's the one basically will be sending it to somebody else. And he's the backup. If this guy fails, then he's going to take over as a designated router. Understood? And then these are the guys who are basically not participating. They are not the ones. If this guy fails, let's suppose it goes down, this is the designated router, then basically they among these three, the election will happen to see who's going to be the backup designated router. When he comes back up, then he takes over the role of a designated router. So there's a whole configuration for it. You know, DR and BDR. The important of this router to have sufficient CPU, we always have selected that the priorities on the interfaces itself. In order for it, the lower the priority is, highest priority wins. So basically, what we used to do, if suppose this is R2, we would put, and we want, let's suppose R2 to be the main designated router, we're going to be putting a priority of 250 or 255, and the rest is basically we're going to have one. So whoever has the 255 will basically become the designated router, because we want to do the election ourselves. We want to configure the router to be the designated router. We don't want the OSPF to basically decide. So IP OSPF priority is basically, this is 255. So 255 will win. Zero is not going to be basically, he's not going to be participating in the election. So he's basically the D rather. Anybody who's not participating in the election will become the DR other. And this, the party is one, he will basically be the designated backup designated router. ASBR says area system border router. What this does, this basically connects to two different areas or going outside of its own network. Any router which connects to the outside network is called ASBR. Default information originate means it's just like a default static route. It says, guys, if you this, let's suppose R2 connects to the internet, right? And R1 and R3 has got, you know, 500, 600, 700 networks sitting behind them. That's fine. But if they want to go to the internet, then you simply configure this under an OSPF, and you're telling your neighbors, my friend, do not drop the packet. If you don't know how to get to it, you simply send the traffic to me and let me take care of it and let me worry about it. How can I get you to the destination? So you don't have to worry about it. Don't drop the packet. So this default information originate means this is a default static route within an OSPF telling my other neighbors, do not drop the packet if you don't know how to get to it. You simply send the traffic to me and I'll make sure I get you to the destination. That's what default information originate means. This is the hello and dead interval. I was saying 4 times or 3 times, whatever. If it doesn't get, if let's suppose it's hello interval is every 5 seconds, and dead interval you have set it up for every 4 times of this 5, so basically 20. In 20 seconds, if I've not got a reply back from my neighbor, what will happen? I will say this connection is dead. So that's what this is. The authentication, this is just MD5 hash. This is basically for your the password encrypt in order to make sure that both routers are connecting to each other. They are basically in sync and they are basically have a password which is matching. If it doesn't match, don't establish a connection. If it matches, then establish a connection, right? So this is just MD5. This is just showing you that Cisco 123, Cisco 123, just making sure that you have the same password everywhere. It's not going to be Cisco 123, but I mean I'm just saying it, right? Area 0, the backbone area, I mentioned it. OSPF does not automatically summarize routes, and therefore routing table can become very large depending on the size of the network. So what happened? You can define yourself basically. Multi-area OSPF basically uses two-layer area hierarchy using a backbone and interconnecting. Because remember, I told you that in the beginning that if you are working in an OSPF, then area 0 is always considered to be the backbone area. And in order for two areas, different areas to communicate with each other, they have to go through area 0. This is how whoever has written OSPF and whoever written the code, this is how they wanted it to be. And any router which sits on two different areas are called area border routers. Any router which is basically on one interface, it connects with the OSPF, and on the other interface, it connects with any other different routing protocols like BGP and ISIS, is called area system border routers. That's a different name for that. But area border routers are the one which is basically interconnecting two areas together. Area 0 is a transit area. You have to go through. This is how they wrote this whole thing, OSPF. You have to go through area 0. Smaller routing table, because you see OSPF is widely used, guys. Seriously, it is widely used. And this is, I've seen basically 20, 30 routers in one area, and, and a lot of routing table in it. 50,000, 60,000, 70,000 routing tables entry in it. Here you go. This is the implementation, 50 routers, but it's 50 routers, but it's less than that, right? We don't want to always cross that 50 and, check how it happens. 20, 15, 20 is maximum more than enough, because you see the routing table is huge. So area border router is here, connecting two areas together. ASBRs is basically the one which connects to the OSPF. On the other end, it connects, could be with BGP, or could be with EIGRP, or could be with anything. So and by doing this, which means that this is a area border routers. Why? Because he has got one leg in area 0 and got one leg in area 1. So which means that he's communicating with two areas at the same time. This is how you configure it. That's it, guys. OSPF. So guys, make sure you guys go through this OSPF. It's got a lot of information. What I have just given you is basically the foundation and understanding of OSPF. Okay. Any question, guys? I'm sorry, I think I missed out on some questions here. This is a message from Pete. If I'm sitting in ISP and I have customers around city to Toronto, how do I configure the router switches to assign IP address to various customers on different areas of the city? Do I have to make a VLAN for the city area? Basically, Wait, what happens is if you're sitting in an ISP, you assign an IP address, right? You go to the what do you call it, internet speed test. And then when you run the internet speed test, what would happen is it will say that this is your public IP address. It gives a public, everybody gets a public IP address. But inside, you don't get a public IP address. Inside, you get a private address, IP config / all. If you look at this, my IP address is this one, 10.0.0.93. My default gateway is this, but my public IP address would be different. I'm getting a public IP address. Understood? All my 254 IP addresses, private IP addresses, are getting converted to my one private IP address. Okay, and what is this? What is this? Okay, I don't know. Any other question, guys? Any other question? No question? Okay. Thank you so much. Appreciate it. Take care, guys.
Thank you, sir.
Thank you.